Okay, so now we're starting in on the calculus portion of the course. And one thing I just want to make clear is that when people hear the word calculus, they get all, nervous about it and so forth. And that's some sort of complicated topic. The one thing you have to remember about calculus is that it really is no different from algebra. Here's what I mean. Assume you have a linear function in algebra, okay? So say x, y, and you have a downward sloping function. Well, this is going to take the form y equals mx plus b, right? Otherwise, we know this as y equals a0 plus a1x, right? A1 is the slope of this function, and it is constant over the entire function, okay? And so, this is easy to figure out. Well, that right there, that is A1, and this, of course, equals rise over run, okay? Now, calculus is simply calculating the slope of a nonlinear function. That's all it is. Okay, so, well, at our level anyway. So, what we're going to do, starting with this portion of the course, is we're going to simply say, instead of having a function like that, we instead have a function that looks like this. And so the slope is different here than it is here than it is here. In other words, the slope is not constant, okay? So it's not going to be just a1 for all x. The slope is going to be something different. And we're going to be able to say, we're going to be able to calculate the slope for functions that look like this. In other words, we're going to have one equation for the slope of this function that will be able to tell us if we plug in this value for x, say value x1, that we will be able to calculate the slope at that point for x1. That if we plug in a value of this of x2, or a value of x, say it's x2, we will be able to calculate what the slope is right there. If we plug in a value for x, say it's value x3, we will be able to calculate the slope of the function right at that point. That's all calculus is, at this level anyway. So what we're going to do in this material that we're getting ready to get into is we're simply going to figure out how do we calculate that slope, okay? Which is different than just saying, oh, well, the slope is m, right? Obviously, this slope is going to take a functional form, not a constant. Now, that said, we have to get through some notation differences, okay? So we've seen already how instead of looking at equations y equals mx plus b, that we now are writing these as functions. So this would be y of x equals mx plus b, and that just means the function, the y is a function of x, okay? So y is on the left, x is on the right. We can turn this around and say f of x equals mx plus b, right? Now that we're working with functions and we're not just working simply with equations, in calculus the derivative form of f, in other words, the slope of f, okay, has a certain notation that goes with it. So the reader can tell, yes, you have taken the first derivative of x, or you've taken the second derivative of x, okay? Now, if we have a function f of x, okay, the first derivative of f, in other words, the slope of f, is labeled f prime most of the time. Most people use this notation, f prime of x, okay? Sometimes they'll just say it's f prime. But other people will say, well, the derivative of f, the slope of f, can be written as df dx, okay? Now, this translated is literally translated as, if I change x by some amount, how much does f change? In other words, rise over run, okay? You can also, think about it or rewrite it as dx f of x, okay? And this simply means the derivative with respect to x of f of x, okay? And this means the same thing too. This means a derivative of f with respect to x. As x changes some amount, how much does f change? And sometimes we rewrite this as using a Greek letter delta instead of just a d, derivative of f of x with respect to x. Sometimes we write it like this. This notation is more common in something called partial derivatives, which we won't get into in this course, but it can still be used interchangeably with any of these different types of notation.